Good morning, everyone, and welcome to today's lecture. In this class, we will continue our discussion of what of your work, power, and energy. We will continue this, and we will try to solve some problems on work, power, and energy using our new friend. And our new friend is known as what? What is the name of our new friend? What is the name of our new friend that we have discovered last class? What is the name of the new friend that we discovered last class? See, we have forgotten the name of the new friend. How will we do questions then? The new friend will get angry.
Law of conservation of mechanical energy.
See, remember, it's such a nice name. It has got a short form and a good ring as well. LOCME is what we call it, and this LOCME can only be applied when they're only when they're only conservative forces are present. If friction comes, then this LOCME is of no use. But most of the question that you're going to see in your examination hall, this friction would not be present, and we can apply LOCME straight away. We had seen one example also in which we had applied LOCME. This question we have done, I think, in chapter number 1 we did it. Here in this chapter we did it by work energy theorem. We again did it by the concept of LOCME, and we found out the velocity with which it strikes the ground. One of the questions we were discussing in the previous class, and I told you that we would be doing it in the next class, and the question goes like this is a hill, a block of mass m is kept on the hill, the block is at rest. Now what we are going, oh, it's already at rest. Now what we are going to do, we are going to drop it. What happens when it reaches ground? We have to find out the velocity when it reaches ground. Remember, this floor is smooth, so there is no friction present. This floor is smooth, so there is no friction present. Friction is absent. How are we going to do this? Well, we are going to apply our new friend. What is our new friend? We are going to apply our law of conservation of mechanical energy, or LOCME, and we are going to apply it from point A to point B. Now, when we are trying to apply LOCME, we must understand that we also think about what are the forces acting on this body. As I see, there is one force which is gravity, which is acting on the body. No problem. Gravity is a conservative force. LOCME can be applied. There is also one more force which is acting on the body. Can you tell me what is the second force apart from gravity which is acting on this body? Second force apart from gravity which is acting on the body. The second force apart from gravity which is acting on the body is normal reaction. Normal reaction from this hill or ground. But what is the work done by that normal reaction? If you ask you what is the work done by normal reaction when this body falls from the top point to the lowest point, what will be the work done by normal reaction? Can anyone tell me what will be the work done by normal reaction? The work done by normal reaction would be zero, because normal reaction would always be perpendicular to the displacement. So even if I consider normal reaction as the other force, the work done by that other force is zero. Now I can apply LOCME. I will take the lowest point as gravitational energy is zero. So at the lowest point I take the gravitational potential energy is zero. Then I can write the statement of LOCME. Total mechanical energy at point A will be equal to total mechanical energy at point B. Now total mechanical energy at point A will consist of two things. Can you tell me what are those two energies at point A? What are the two energies that we have to consider at any point A or point B? Anyone? What are the two energies that I have to consider at point A or point B? No one knows it? What do you mean by mechanical energy, beta? Can anyone tell me what do you mean by mechanical energy? Anyone remembers what is mechanical energy? Does anyone remember, beta, what is mechanical energy? No one remembers that as well. Okay. Mechanical energy is the sum of kinetic energy and potential energy. The sum of kinetic energy and potential energy at point A, that is mechanical energy at point A, that has to be equal to sum of kinetic energy plus potential energy at point B. Total mechanical energy at point A will be equal to total mechanical energy at point B. Now, can you tell me what is the kinetic energy at point A? Anyone? Kinetic energy at point A. This is the point A. Can you tell me what is the kinetic energy here? Anyone? It is at rest over here. Can you tell me what is the kinetic energy here, beta?
0, sir.
Okay. Kinetic energy is 0. What is the potential energy at point A? This height is taken as h, is given as h.
mgh.
Yes, very good. Plus mgh. Okay. Now let us go move on to point B. What will be the kinetic energy at point B? I have to find out the value of VB. So what will be the kinetic energy at point B?
Half mv square.
Right. I can write it as half m into velocity at B square. What will be the potential energy at point B?
0.
Because it is the lowest point and I have taken the energy of the lowest point as 0. This is very simple. Now you can find out the value of velocity at point B, and the answer that you will get, velocity at point B, will be equal to root over 2gh, and that is the answer that we are looking at. So this is how we apply the concept of LOCME, law of conservation of mechanical energy. Do we all understand this, yes or no?
Yes, sir.
Okay, I'll give you 2 minutes to note it down, and then we will move on to the next question. 2 minutes, please note it down. Then we will move on to the next question, and this is the next question that I have created for you. A simple one. Here we have a wall and a spring of spring constant K. Do you remember spring constant K? Yes or no? Okay. Spring of spring constant K, and a block is moving, and remember this surface is smooth. There is no friction present here. Since there is no friction present here, we can think about applying LOCME. Now, a block of mass m is moving on a smooth surface with a velocity v. So what all things are given to you? The things that are given to you is the mass of the body m, the velocity of the body v, and the spring constant k. All these three yellow things are already given to you. Now what will happen is when it strikes the spring, it will start to compress the spring. Yes or no? Yes or no? The spring will keep on getting compressed, and there will be a time when spring has maximum compression. Yes or no? That is the question. That is what you have to find out. Find the maximum compression in the spring. Find maximum compression in the spring. What all things are known to you, beta? The mass of the block is known to you. The velocity of the block is known to you. Spring constant K is known to you. And it is also known that the floor is smooth. You have to find out the maximum compression on the spring. I'll give you 2 minutes. Please try it. Let me know once you are done. After 2 minutes, we will solve this question. Okay. Your time begins now. So how are you supposed to do this? Well, again here, there are how many forces working here? Can anyone tell me how many forces are working here in this question? How many forces are working here in this question? How many forces are working here in this question?
3.
There are three forces which are working here.
Second.
The first one is gravity. Is gravity doing any work? The gravitational potential energy is same. So
No.
gravity is not doing any work. Yes or no?
Yes, sir.
Then the next one is normal reaction. Is normal reaction doing any work?
No, sir.
No. So gravity and normal reaction gone out of the picture. Then there's only the third one which is remaining. About what is the third one which is remaining? That will come when the block starts to compress that spring. Yes or no?
Yes, sir.
Okay. So now you can apply. Let me call this point as A. This point could be the point where it is going to strike the block. The block is going to strike the spring, and then I will apply it from A to B. Now B is the point where the block compresses the spring and the spring is under maximum compression. So your X is your maximum compression. Do we understand this? Now at this point B, which is the point of maximum compression, the block is not going to go any further. In fact, the block will start to move in the opposite direction. So velocity at point B of the block will be equal to 0, because that is the point of maximum compression. After that, spring will not go any further down. It will try to push the block back. Do we understand this? Yes or no? So what we have to understand here is there are three forces. One is gravity, no work done, forget. One is normal reaction, no work done, forget. The third is only spring force. And at the point of maximum compression, the velocity of the block becomes 0. Do we understand this, everyone? Now I am going to do the simplest possible thing. I am going to apply my new friend LOCME from point A to point B. And what does LOCME say? LOCME says that mechanical energy at point A plus kinetic energy, mechanical energy at point A should be equal to mechanical energy at point B. Now, the mechanical energy at point A consists of kinetic energy at point A plus there are two potential energies at point A. One is the gravitational potential energy, which is 0. We understand this flat surface. And one is the spring potential energy. So this UA is the spring potential energy. Mechanical energy at point B will be kinetic energy at point B plus the spring potential energy at point B. Now, can anyone help me in telling me what is the kinetic energy at point A? What is the kinetic energy at point A?
mv square.
Kinetic energy at point A is half mv square plus the spring potential energy. There is no spring force, there is no spring, there is no compression, there is no extension. So spring potential energy is 0. Now can you tell me what is the kinetic energy at point B?
0.
Kinetic energy is point B is 0. What will be the spring potential energy at point B? Remember the spring is now compressed with a distance x. What is the spring potential energy?
The spring potential energy half kx square.
Very good, bacha. Half kx square. That is the spring potential energy. Now these both terms are equal. Now you can easily find half and half getting cancelled, my dear friends. So your maximum compression x will be V times root over k by. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this? Can I have raise hands from everyone that we understand this?
Everyone.
Well done. I will give you a minute to note this down. And then I'll give you one more question to make the point absolutely clear in everyone's mind how we apply this work energy theorem in different cases. Let me know if you are done, bacha. Everyone has done?
Yes, sir.
Okay, I think that thing stopped. So I will just open that thing. A question is ready for you, and I sincerely hope that you are able to solve this. So, in this question, what you see is a block kept on the top of a hill at rest. Then I have got a smooth ground. I'm going to leave this block from that point. What will happen? It will start to move down, yes or no? There is no friction present anywhere. Then it will go and get in contact with the spring and it will start to compress the spring. Everyone understands this? And at one point, the spring will be under maximum compression. You have to find out the maximum compression in the spring. As you can see, this question is nothing but what I have done is I have added two questions. Can anyone understand which questions I have added here? The first question that we did in the class, it was only till the ground. Then the next question which we did was on a ground with spring. The third question, I have added the two and made the third question, my dear friends. So this is the third question and I will give you 2 minutes to solve it. Please solve it. If you can get the answer, nothing like it. Your time starts now, beta. So, how are you supposed to do this? Again, how many forces are at work here? One is gravity, one is normal reaction, and one is spring force. Normal reaction is not doing any work. Only two forces are doing work. One is gravity and one is spring force. Do we understand this? Yes or no? Let me call this point the initial point as A, and let me call this final point where the compression is maximum as B. The maximum compression, let me call it as X. Can anyone tell me what will be the velocity at point B? Point B is the point where the spring has reached its maximum compression. What will be the velocity at point B, beta?
Zero.
What will be the velocity at point B, beta? Spring is in maximum compression. What will be the velocity at point B?
Zero.
It is going to be zero because spring is not going to go, the block is not going to go anywhere. Let me take the gravitational potential energy of the lowest point as zero. Now, I am going to apply the law of conservation of mechanical energy, LOCME, from the initial point A to the final point B. Initial point A to the final point B, total mechanical energy at point A will be equal to total mechanical energy at point B. All of us understand this, yes or no? Now, total mechanical energy at point A consists of kinetic energy at point A plus potential energy at point A. This potential energy is in the form of gravitational potential energy because there is no spring energy. Do we understand this? Total mechanical energy at point B will be kinetic energy at point B plus potential energy at point B. At point B, I have taken gravitational potential energy as zero. The only potential energy it will have will be spring energy. Do we understand this? Now, what is the kinetic energy at point A? Can anyone tell me that?
Zero.
Kinetic energy at point A is zero. Well done. What is the potential energy at point A?
mgh.
It is gravitational potential energy and it is equal to mgh. Very good. What is the kinetic energy at point B?
Half mv square.
Kinetic energy at point B. At point B, it is maximum compression. The block is going to stop. So the kinetic energy is going to be zero. Plus, what is the potential energy at point B? Half kx square. Do we understand this, everyone?
Yes, sir.
From here, you can find out the value of x. 2 mg h by k. The under root of this thing is the maximum compression in the spring. Everyone understands this, yes or no? I'll give you 1 minute to note it down, and then I will give you one question, and I hope that you are able to solve that question. Have you noted down the answer, beta?
Done, sir.
Well, then comes the next question. Question number 4. And I hope that you all can do this. So the question is pretty simple. I have a block of mass m kept at rest on an inclined plane. The value of the mass is m. The height of the incline, the height of the highest point is h. The surface is smooth. It will fall down and then it will compress the spring. You have to find out maximum compression in the spring. I'll give you 2 minutes to think about it, and I hope that you can solve this question. Your 2 minutes, your time starts now, my dear friends. So, how are we going to solve this question? I will call the highest point as point A. I will call this point where it reaches its maximum compression as B. The distance the spring is compressed, let me call this as X. Can you tell me what will be the velocity at point B, where it is under maximum compression?
0.
Velocity at point B is going to be 0. Well done. Now I'm going to apply LOCME, law of conservation of mechanical energy, from the highest point to the lowest point. I call the lowest point as potential energy, gravitational potential energy as 0. Now, total kinetic energy at point A plus total mechanical energy, total potential energy at point A, what I am talking, should be equal to kinetic energy at point B plus potential energy at point B. Can anyone tell me what is the kinetic energy at point A?
0.
Why it is 0? Because it is at rest. Plus, what is the potential energy at point A?
mgh.
That is gravitational potential energy, mgh. What is the kinetic energy at point B? What is the kinetic energy at point B, beta?
0.
Kinetic energy at point B is 0. What is the potential energy at point B?
Half kx square.
Half kx square. From here, you can solve for the value of x. And what is the value of x that you are going to get, beta?
Under root 2 mgh by k.
Under root of 2 mgh by k. So that is how we are supposed to do problems of this type. Everyone understands them? Yes or no? No, yes. Everyone got this? How we are applying this law of conservation of energy and how we are getting the answer for this? Yes or no? No, yes. Okay, then there is a question that has come in one of your previous year papers. Okay, so I'll give. Okay, so this is a question that has come in your paper. I will give you this. This is work done. We have already done this. Let me see if there is any question here. Yes, here you will have. Okay, this one. Comes for you. A 2 kg block is dropped from a height of 0.4 meter on a spring of 4 constant 1960 Newton per meter. You can take G as 9.8 here. Take G as 9.8. What is the maximum compression in the spring? Can you do this? Yes or no? You've done difficult question than this. I think you can do this. I'll give you 2 minutes. Try this. 2 minutes and give me the answer. So, have you done this, bacha? Yes or no? Anyone got the answer? So the question I think was like this. There was a spring of spring constant K and there was a block of mass m, and this block was kept at a height h. Again, you had to apply LOCME from point A, the highest point, to the point B, where the maximum compression in the spring is X. So you apply LOCME from point A to point B. Kinetic energy at point A plus potential energy at point A should be equal to kinetic energy at point B plus potential energy at point B. What is the kinetic energy at point A? Yes, tell me. 0. What is the potential energy at point A? You can call the potential energy of the lowest point as 0. So the potential energy of the highest point becomes mgh. Yes or no, beta?
Yes, sir.
That will be equal to kinetic energy at point B. It is 0. Yes or no?
Yes, sir.
Plus potential energy at point B half kx square.
X
From
equals
here
to
you
under
can
root
find
A
out the value of
mgh
x
by k.
2 mgh by k. Yes or no?
Yes, sir.
That is what you have to find out. Remember, here we have taken the assumption that this x is very, very small compared to h. Otherwise, the equation will become somewhat complicated. Do we understand this, everyone?
Yes, sir.
Everyone got the answer? Can I have raised hand that we got the answer, sir?
Answer.
You got the answer for this one? The answer for this one, the value is, how much is the value? Is 0.1 meters. Option A. Did you get the answer? Option A, 0.1 meters. Okay, you can calculate it on your own. Or shall I tell you how to calculate? Do you know how to calculate it, beta?
Yes, sir.
Under root of 2 into 2, G is 9.8. Height is 0.4 divided by 1960. Okay. So leave about the calculation part. Do you understand how this is done? Yes or no? You understand this? Okay. Now this is again one of the questions which may come in your exam. A stone is projected vertically upwards. Question number 7. A stone is projected vertically upwards from the ground, reaches a maximum height h. When it is at a height 3h by 4, what is the ratio of its kinetic and potential energies? So it reaches up to a maximum height h. What is the ratio of its kinetic and potential energies when the height is 3h by 4? So I'll give you this question as homework. You try this question as homework, and in the next class we will find the solution. We will discuss the solution of this question in the next class, and we will also discuss the concept of power, which is the last part of this chapter, and we will probably finish this chapter by the next class. Can you try this question at home? Have everyone written this question, yes or no? Please try this question at home. In the next class, we will try to wind this chapter of work, power, and energy. Take care. Have a good day. I hope everything is clear in today's class. Yes or no? Take care. God bless all of you, bacha. Bye bye.